Okay, so today's assignment, we're going to continue. Please remove the earbuds. Today's assignment, we're going to continue 1-6 over absolute value equations and inequalities. This is part 2. Our objective is to write and solve equations using inequalities involving absolute value. So right now I want you to work on the spell work that says explain the diagram below in your own words. So if you look at this, what is this and what does it mean? So explain it in your own words in your journal. Okay, after you finish that, I'm going to give you 5 minutes here to get your assignment out and make sure you finished everything. And if you can, work the rest of the first page. There were 4 more problems on the front page. See if you can finish those next 4 problems, which would be through 16. Okay, and do the best you can do, and then we're going to move on. Okay, I'm going to go ahead and pause the video now. Start the timer. There we go, and I'll come back when the timer's up in 5 minutes. So pause your video now. Okay, so 5 minutes is up. Could somebody explain this diagram? What did you write on your paper? Yes.
I wrote x is greater than -5 and x is less than 5.
So you wrote x is greater than
Yes, x is greater than
-5 and
x is less than 5.
so the words and x is less than 5. That's one way to write it. Did anybody else write anything different? That's sort of like still in mathematical speak there. How could you explain it if you were writing a sentence out without using all the math symbols? That's sort of where we were headed there. But that's a good way to look at it. And that's exactly what it is. It's not a filled in dot, so it's not greater than or equal to, or less than or equal to. It's just greater than -5, because it goes this way, and it's less than +5. Did anybody write anything differently? Are you just too shy to speak? All right, I'm not going to spend any more time on this. Let's move forward with our assignment from yesterday. I want to remind you of the inequality symbols. We've got greater than or equal to, less than or equal to, and we have a not equal. Okay? Then with our compound, we've got the and or. Excuse me. Before we go on, I want to give you the answers to your first page. And before long, when I have the trays up here with all your supplies or boxes, whatever I've got to put up here, you would get a red pencil out so you could grade your papers. I see a few people, couple, maybe 1 or 2, that keep their backpack in their lap and the phone's right on top of it. Guys, phones need to be out of sight and your backpacks need to be in a chair. Okay, so please take care of that now. And it's usually the freshmen that I have to tell over and over because you're in a new place and you're just not used to the rules and what we have to do. But you do need to put your bags up. So could you please put your bag in the next chair? Where the floor is fine. Okay, thank you. All right, so the answer to number 1 was x, and I'm not going to do the graph. I'll just give you the answers. X is equal to 6 or x is equal to -6. 2, y is equal to 4 or y is equal to -4. 3, t is equal to -6 or t is equal to -8. 4, z is equal to 5 or z is equal to -7. 5, w is equal to 2 or w is equal to -3. 6, x is equal to 3 or x is equal to -1. 7, y is equal to 0 or y is equal to 5. 8, z is equal to 6 or z is equal to 4. 9, x is equal to 9. 10, t is equal to 5. 11, y is equal to 2 or y is equal to negative 1. 12, y is equal to negative 2. Now that was your homework over the weekend. Now today I said if you can, work as far as you can on 13, 14, 15, 16. So the answers can vary because there's more than one way to answer these. But here's a sample answer. You might have said the absolute value of x is equal to 3 on number 13. The absolute value of x is equal to 3. So that would give you the positive 3 and negative 3 would make that true. 14, when you look at this 14, whoa, what happened here? On 14, they give you, because a lot of students ask me, how do you know this? How can you figure this out? Well, if you've got a number line, and we've got a solid dot on negative 4, and a solid dot on negative 2. Oh, it's frozen. I am so sorry. Be sure and tell me when I don't do that, because when we freeze, there we go. So here we go. Again, I've just written this out here. On 14, you've got a solid dot on negative 4 and a solid dot on 2. So it says write an absolute value equation to describe each graph. So what you need to do is say, well, you're going to have, there would be a negative 1 and a 0. Still going this way. So we have 2 points, and we know absolute value, you're going to do a positive something and a negative something. So an opposite. So if these are the 2 points you're talking about, and these were opposite or equidistant from a center point, what would that center point be? Well, you've got 1 unit from negative 4 to negative 3, and 1 unit from negative 3 to negative 2. So we know that whatever we have of an absolute value, we're going to add 1. So we have equal to 1. So how do you know what goes in here? X. X plus something equal 1. So what would we put in here to make this equation true? The absolute value of x plus something is equal to 1. So what if I put in a 0? Hold on. So there's lots of things we could put in here. Well, I'm going to say because we are 1, 2, 3 units back on the center point, I'm just going to start with a 3 here. So if we look at this, we've got x plus 3 equal 1, the absolute value of x plus 3. So what happens if we put in a negative 4? So the absolute value, negative 4 plus 3 is a negative 1. So does 1 equal 1? Yes. So that makes this true. So what happens if I put a negative 2 in there? Negative 2 plus 3 also makes a 1. So see, they are 1 away from that center point, 3. So that's one way to do those, but there's many, many, many answers. It's just one way that I like to figure them out. Okay, but always put in numbers at the end and check your answer. Whoops, didn't mean to do that. There you go. All right, let's move on. It says, is the absolute value equation always, sometimes, or never true? Well, if I had the absolute value of something, here they've got a W, equal to -2, is there ever a case where anything, the absolute value of anything would be negative? No, so that would be never true. The next one, you've got the absolute value of z plus 1 equal z plus 1. Well, if this had been an absolute value, then we would have an easy thing, right? But it's not. Oops. There we go. It's not. So we've got something here outside of an absolute value. So that sort of changes the equation. So could this be a true statement? It could sometimes. It depends on what z is. If z is less than 0, we've got a problem, right? Because what would happen if z is less than 0? So we've got an absolute value of -1 plus 1 equal to -1 plus 1. So you've got, that's going to be a 1 plus 1, which is 2. -1 plus 1 is 0. 2 does not equal 0. So anything less than 0 is going to cause this a problem. Okay, that's the teacher's emailing me back for subs, so I think I better go call in a sub for tomorrow. All right, so what you would say to qualify this, because this will work for any positive number. And how do you know? Well, if you just don't see it quickly by just doing some mental math, then just go ahead and plug in numbers and see what happens. Well, check a negative number, check a positive number, check a 0. So what happens if it's 0? So we'd have 0 plus 1 equals 0 plus 1. 1 does equal 1. Yes, that checks out. So if we plug in any positive number, let's do a 2. 2 plus 1 is 2, or excuse me, is 3. Can't add. And then 2 plus 1 over here is 3. 3 equals 3. So it looks like it's going to work for any positive number. The only time these two guys change is when it's negative, because that guy would go to a positive and he's going to stay a negative. So what we have to do is say, well, this is true sometimes. It's going to be true if z is greater than or equal to 0. So you'll say sometimes when z is greater than or equal to 0, it's true. Okay? Any questions? All right. I spent more time on those than I did with any other class today, but usually you guys finish a lot quicker than my other classes. Let's look at our problem number 4. If I can find it again. There we go. So it says, solving an absolute value inequality, absolute value of A is less than B. So when things are less than, we're going to solve them one way. And when your absolute value has a greater than, we're going to solve it another way. So what we're talking about right now is just the less thans, when it's smaller, less than. It says, what is the solution of the absolute value of 2x minus 1 less than 5? Graph the solution. So when it's less than, this is the way I remember it. If it's less than, I have one statement, or one equation, or inequality, excuse me, one inequality. If I have greater than, then I'm going to have two separate inequalities. You okay? And guys, just for the record, if you're someone who's prone to having nosebleeds and you have a very bad nosebleed, if you grab a bunch of tissues and run out the door to the bathroom, I'm not going to say a word. If you are dripping blood, you know, and just let me know. If usually I'll go check and see if you dropped anything on the floor, because we have to call for special cleanup for body substance, okay? So just get up and run. You're excused. No one's going to get onto you. But runny nose, whatever, yeah, just grab tissues. And if you're really sick and you're sitting there blowing and blowing and blowing, just take a box to your desk with you. No one's going to say a word. And just give it back at the end of the hour. All right, and just throw away your tissues, though. So, what is the solution of 2x, absolute value of 2x minus 1 less than 5? Graph the solution. Well, this is less than, and I said if it's less than, it's got one inequality. So, let's look at what this looks like. We're going to make it a compound inequality because it has 3 parts. So, how do we do this? The 2x minus 1 is less than 5. I think I've got it here. Nope. There it is. All right. So right here, what we have to do is say, okay, well, we could make 2 equations, but it's better off just to do 1. And what we want to do is take the opposite of this last number, okay? But make sure that you have first isolated your inequality. So you would solve, you would get rid of any, like if it was 2 times, you would get rid of that by, you know. So you want to isolate your absolute value. Once your absolute value is isolated, now we can go to work and fix our equation. So you want to look at this. So we've got a positive 5, so let's flip this. The opposite of positive 5 is a negative 5. Keep your sign, less than, and now we're going to remove the absolute value symbols to x minus 1 less than 5. So just a straight copy. The only thing new here was this and removing the inequalities. Is everybody with me? All right. Next, we're going to start solving. So this is from Algebra 1. You're going to have to isolate this x in the center of the equation here. So start with the furthest thing. So I'm going to add 1. If I add 1 there, I must add 1 to this side, and I must add 1 to this side. So these go away. And now, negative 5 plus 1 is negative 4, less than 2x, less than, and 5 plus 1 is 6. And I'm still not finished. Now I've got to still isolate my x, so I've got to divide by 2. And if I divide that by 2, I have to divide all terms by 2. So now that simplifies to negative 2 less than x, because those cancel out, and that goes to a 3 less than 3. So there's my final equation. Negative x is greater than negative 2 but less than 3. So how do you graph these? Well, you look at your boundary points. Negative 2 and 3. So I'm going to put a negative 2, negative 1, 0, 1, 2, 3. So I'm going to put an open circle here on both of them. And this is how I always do it. Now I look at the symbol. It's just less than, just less than. Neither one of them has or equal to. So I'm going to leave them as open circles. Now let's take each side. X is greater than negative 2. So it's greater than. So I'm going to shade to the right. And I'm going to go about halfway and stop. Now I'm going to look at this side. X is less than 3. So it's going to be there. So there's my graph and my inequality. Okay, and I scribbled all over this. So let's see if I can get those marks back out. All right, so there it is. So there's my solution and my graph. X is greater than negative 2, but less than 3. And less than 3, I should say. This is an and. So for the less than, this is how you do all less than compound inequalities. All right, any questions? All right, let's go to your workbook. So flip it over on the back of 1-6. And look at 17. So we have 2 times the absolute value of x plus 5 is less than or equal to 8. So it's less than. We've got a less than symbol there, so we know we've got to isolate our absolute value, so it means we have to get rid of the 2 and then rewrite our equation, okay? So let's do that. So I'm going to divide each side by 2 to clear this, and I'm left with x plus 5 is less than or equal to 4. Now I'm still not finished. Oops, excuse me. Still not finished, right? So now I've got to rewrite this inequality, the absolute value inequality. So this is a positive 4, so I'm going to flip the sign here, negative 4. Keep the inequality, and now drop the sign, x plus 5 less than or equal to 4. Now solve for x. So now I'm going to subtract 5 here, subtract 5 here, subtract 5 here. And this goes to 0, this goes to negative 9, less than or equal to x, less than or equal to negative 5 plus 4 is negative 1. So now we've got x is greater than or equal to negative 9, but less than or equal to negative 1. So I have my boundary points again of negative 1 and negative 9. All right, so at negative 1, I'm going to mark both of my boundaries. Now I'm going to look at my symbols. They're less than or equal to, less than or equal to. Because they're equal to, both of them, you're going to fill in the dots. Now look at each side. X is greater than or equal to negative 9, so we're going to shade to the right. And on this side, x is less than or equal to negative 1, so shade to the left. So there it is. Okay. So now we've worked 2 together. Are there any questions? Got 2 examples to go off of. We're going to work these in just a minute. I'm going to give you class time. Okay, let's look at what happens when it's greater than. We've been working when it's less than. What happens when it's greater than? Well, we have to solve it differently. So if it's greater than, we've got to make 2 separate inequalities. So here's our first example. 2x, absolute value of 2x plus 4 greater than or equal to 6. All right. So what we have to do is write 2 inequalities. So, whoops, let me back up. So the first thing we need to do is rewrite them both. Remember, when you do the negative or the opposite, you've got to flip the sign. So here, let me blow this up. So we're going to go to here. 2x plus 4 less than or equal to negative 6. So you got to change that sign and flip the inequality. And then this side is just going to be 2x plus 4 greater than or equal to 6. Is everybody with me there? So when it's greater than, you've got 2 equations. When it's less than, you have 1 equation with the 3 parts. Now, isolate your x, your variable. Okay, we're going to isolate the x's. So let's do the left side first. So I'm going to subtract 4 from each side. Right? And we get 2x is less than or equal to negative 10. Divide each side by 2, and you get that x is less than or equal to negative 5. So there's 1. Now on this side, we're going to subtract 4, and you get 2x is greater than or equal to 2, and then divide each side by 2, and you get x is greater than or equal to 1. So there's our two inequalities. Now, when we had a less than, it was one equation with three parts, and we had one segment. Now, when you have a greater than with the two equations, you're going to have two portions of a graph. I should say two segments with the gap in between. So here we have a -5 as our boundary, and then let's just do a 0 and a 1 there. Right? So I'm going to do my open dots there, and I'm going to look at my symbols. Less than or equal to -5, so it's also equal to, but it's less than. So it's going to go this way. X is less than or equal to -5. And on this side we have x is greater than or equal to 1. So greater than or equal to. So now we have two segments. And remember, I told you about the segment, playing on words, and a gorp, with the segment and has a segment, and gap is with the or when you have a gap. Well, this is like your or. So when it's the greater than, you've got a gap. You have two segments to draw, two separate segments with the gap in between. And I said, remember the word gorp, my made-up word, to remind you that or makes the gap. Okay? So this is, when it's greater than, it's like the or. When it's less than, it's like an and. Are there any questions so far? Okay, you're awful quiet, and I know it's late in the day, so let's go on to our workbook. Let's look at number 19, and then I'm going to let you do the rest by yourself. So, 19 says, the absolute value of 2z plus 2 minus 1 is greater than 3. Okay? So, is it greater than or less than? Say it. Greater than. Good job. So that means we're going to have the two separate equations. When it's greater, it's 2. When it's less, it's the 1 with 3 parts. So we've got to make the two equations. Oh, but before we do that, we have to isolate our absolute value. We've got to get rid of that. Then we can split the equation up. So don't jump your gun there. All right, so now I'm going to add 1 to each side. So we have the absolute value of 2z plus 2. That goes to 0, greater than 4. Now we can do it. So for the two equations, I'm going to flip my sign, flip the sign on the 4, and flip my inequality symbol. So it's going to be 2z plus 2 is less than -4. And then for the positive, it's going to be 2z plus 2 is greater than 4. Everybody with me? All right, now solve for x on both sides. I'm sorry, z, not x, z. We got a z this time. So we're solving for z. So I'm going to subtract 2 from each side, giving us 2z is less than -6, so z is less than -3. And over here, I'm going to subtract 2 from each side, giving us a 2, and then divide each side by 2, and we end up with z is greater than 1. So there's my two inequalities. And remember, it was greater than, so we know it's going to be a gap. There's going to be a gap in the middle. What's our boundaries? 3 and 1. -3 and 1, excuse me. -3, so we go 2, -1, 0, and 1. So I'm going to have a dot there and a dot there. Now look at your symbols. They're just less than and greater than. There's no equal to on them, so we don't fill in the dots. So now let's look at what these inequalities say. Z is less than -3. So it's less than -3, so it's going to travel this way. So shade to the left. And for this one, Z is greater than 1. So it's greater than 1, so you're going to shade to the right with an open circle. Okay, so any questions? All right, I've done one each out of your workbook, and I want you to spend the rest of your time in here to work 20, 22, 20, 21, 22, and 23. But if you look at 20 and 22, those are both less than problems. 21 and 23 are both greater than problems. So that should help you out. But that's all we're going to do today, and then we're going to turn them in. So spend the next 16 minutes doing those 4 problems, okay? And this concludes our lesson. Thank you for watching.